The fourth content will be OTN overhead. So let's go together with the OTN frame structure. So we are starting with the first one, which is OPUK payloads, and following for the rest, which is ODUK level and OTUK level, and last but not least, which is alignment. So let's go through with the OTN's overhead. We call it from byte number 1 until byte 16. So the first one will be the FAS, as you can see, alignment, which is byte 1 until byte 6, and following for the OTUK overheads, which is the green color. And the purple color shows the ODUK overheads, and the orange color shows the OPUK overheads. Frame alignment signal from byte 1 until byte 6. As you can see, frame alignment is very, very important in the OTN frame. As you can see, for 1 byte, it contains of 8 bits for the frame alignment processing. The second one will be the multi-frame signal, which is in a byte number 7. So multi-frame alignment signal is a similar function like a FAS. So as you can see, they can support a multiple frame alignment that will come to this OTN frame. OTUK section monitoring. As you can see, the green color shows in front, which is section monitoring from byte 8 to byte 10. So section monitoring, they have 3 very important content, which is, we call it T, TI, BIP, and even several bytes there. The first one, let's go through with the TTI, Trace Trail Identifier. So as you can see, Trace Trail Identifier, it contains only 1 byte, and to recognize where is your source and where is your destination of your frame. So the next one will be other byte. In the same section monitoring, we call it BIP8. In this content also, you will see they will copy the first frame, they will copy for the second frame to recognize and to make a comparison at the end of the frame in the destination. OTUK section monitoring overheads, the last section monitoring bytes, which is this byte. And they have several bytes that they can support for the monitoring. OTUK GCC0 and RES overheads. There are 2 bytes that support of this OTUK level. GCC0 byte is under the OTUK level, which is it is used for the electrical supervisory channel. And RES overheads is used for the future standardization. ODUK path monitoring overheads. So this level, it will show you the overheads in the ODUK level, which is the purple color there. In this path monitoring, they will have several bytes such as this particular byte. It's almost same function like a section monitoring. In this byte of ODUK path monitoring, it doesn't support such as BIAE bytes. For the status here, it will show you the condition of a bits from bit 6 until bit 8. If it is show the 001, means this is the normal path signal. ODUK tandem connection overhead. This tandem connection overhead is used to monitor if you had different operators. They can support up until 6 tandem connection monitoring. In this byte also is the same like section and path monitoring. It will have such as TTI, BIP, and the rest. It's the same like a state with the other path monitoring and also section monitoring, which is the condition from bit 6 until bit 8. So if it shows 001, means this is a normal. Nested and cascaded ODUK monitored connection. So in here we have a tandem connection 1 until tandem connection 6. As you can see, nested. Nested means from B1 to B2 and they will nested to C1 and C2. That's what we call nested. For the cascade, which is near to near, which is from B1 to B2 and B3 to B4. So that one, we call it cascaded ODUK. So the next one will be the overlapping ODUK monitored, which is from C1 to C2 and we're combining with the B1 to B2. That one, we call it overlapping ODUK. ODUK G601 and G602. It's similar like a G660, which is it is support for the electrical supervisory channel. As you can see, they're using 2 bytes there in the ODUK level. So the other overheads also, they contains a lot of function similar with the other layers. So OPUK payload structure identifier is used for the concatenation process, which is the payload where is your client services will be mapped. And last but not least, which is the OOS. This is where your Lambda OSC carry your overheads and your payloads. Thank you for watching.